Good day and welcome to my video lectures about physics. In this video lecture, I will discuss about the concept of Newton's first law of motion. So let's start. So what is the main idea behind Newton's first law of motion? The law states that an object at rest remains at rest, or if in motion, remains in motion at a constant velocity unless acted on by a net external force. So let's illustrate this. Let's say I put a 10 kilograms block on the flat surface and the block is not moving. That block is going to stay at rest unless you push it. If you don't apply a force, that block is going to stay where it is. However, if you apply a force, and if that force is strong enough, the block will begin to slide across that surface. So if you want to cause an object to move, it requires an action wherein you need to apply a force, either a push or pull action. You can push the block to the right or you can pull it using a rope. Either case, a force is required to accelerate the object. If no force is applied to the object, that object will remain at rest. Now what about the second part of the law, which states that an object in motion continue in motion? Let's say we have a ball placed in a carpet and you push the ball. So the ball is moving, and what will happen if the ball is rolling against a carpet floor? That ball will eventually come to a stop. Now why is that? Because Newton's first law states that an object in motion continue in motion unless acted on by a force. Why does the ball when rolled against the carpet come to a stop? The reason is there a friction between the ball and the carpet. And so friction is a force that opposes motion. Friction always causes the object to slow down and eventually come to a stop. So there is a net force acting on the object, and that is friction. Let's say if we will reduce friction, let's say rolling a ball on a smooth ice surface and giving a push. What is going to happen? Will the ball going to stop? What will happen is that the ball will roll against the smooth ice for a very long time, and it will travel a long distance before it will stop. In reality, there is friction in the ice surface, but that friction is a lot less than what you will find against the carpet. Now, what are some ways in which we can greatly reduce friction to almost zero? One example is on space. Outer space is virtually empty. Molecules are almost not present in outer space. So if you throw a ball in outer space, that ball will continue to travel unless it will encounter another object. It is going to travel straight as long it is not affected by the gravity of a nearby planet or a star. Let's say an astronaut in outer space, and he is far away from Earth and other planets. All there is the astronaut and a ball in his hand. Let's say he decided to throw a ball. Now what is going to happen if he throw the ball to the right? If the ball does not encounter an asteroid or some other object, it is going to continue to travel at the speed that he gives. So it is not going to change the direction. It is continue in a straight path. Let's say the ball eventually reaches near the planet Earth. The gravity from Earth will eventually make the ball to turn towards the Earth. Therefore, a net force can change the motion of the object. But if there is no net force, the ball will continue to travel straight. Now, now I want you to give a few situations and I want you to determine if there is a net force acting on an object. Let's say if a ball is moving straight to the right at constant speed. Is there a net force acting on the ball? The answer is none. The net force is zero. Now let's say a ball is moving to the right with initial speed of 30 meters per second. And then 1 second later, the velocity is 35 meters per second. So the ball is accelerating. The question is there a net force acting on the ball? The answer is yes. Because anytime an object is accelerating or anytime the speed is changing, there is a net force. Now if the speed of the ball is changing 5 meters per second in every second, it means that the acceleration is 5 meters per square second. Acceleration is the change in velocity that occurs every second. Now let's say we have a ball travels at constant speed of 20 meters per second, but it is turning also at 20 meters per second. Is there a net force acting on the ball? The answer is yes. Notice that the ball does not moving in one direction only. It changes its direction. So anytime an object changes direction, there is an acceleration, and that acceleration is perpendicular to the object, and the net force is always in the direction of the acceleration. So although the speed is constant, it does not always mean that the net force is zero. The only way the net force is going to be zero if the object is not moving or it is at rest or the object is moving at constant speed in a single direction. The best example wherein an object is moving at constant speed but it changes direction is the orbiting of a planet Earth around the Sun. There is a net force that makes the Earth turning in a circle around the Sun, and that is the force of the gravitational field. Keep in mind that there is always a force of gravity between two objects. The Earth also exerts a gravitational forces on the Sun, and these forces are equal according to Newton's third law of motion. Newton's third law states that for every action there is an equal and opposite reaction. So a force like gravitational force does not make an object to speed up or slow down, but it changes the direction of an object. Thank you.